Then next we have a question that the population of a country grows at the rate of 3% per year. So here we have that the population is growing at 3% per year. We are required to frame a differential equation for the given condition for the showing the rate of growth of the population. So let's say at present the population is t, right? At present time, let's say t years, the population is x. So the variation of population with the time, they have clearly stated in the question that the change of population with respect to time is 3%. So would be 3%, that is 3 upon 100, and it's of times the x. So just simple removing proportionality sign, we have this equation. So rate of change of population, that the population increases at the rate of 3% of x. So this is the differential equation which will help in calculating the population after some t years. Then next we have is there is a spherical raindrop which evaporates at the rate proportional to its surface area. So a raindrop, it is evaporating, right, and that the rate of evaporation they have given that evaporation is proportional to surface area, right, and we are required to form a differential equation indicating the rate of change of radius of the drop. So we are required to form a differential equation which must have this term, rate of change of radius of the drop. So here the question must be very well understood that as the drop evaporates, it's not only the surface area that will change, it's also volume which will change. So taking raindrop as perfectly spherical in shape, its area is given by 4 pi r square and the volume of the sphere 4 by 3 pi r cube. So how will you relate the equation? How will you start it up? So rate of evaporation, right? Evaporation is dependent on the surface area, right? We are required to find out the rate of change of radius with respect to time. So to start with, right, the evaporation depends upon the surface area, and evaporation, it is nothing but rate of change of volume, and it is dependent on the surface area. So dV by dt is equals to k times the surface area A. Differentiating volume with respect to time, 4 by 3 pi 3 r square dr by dt is equals to k times, and the area we are given as 4 pi r square gets cancelled, 4 pi gets cancelled, 3 gets cancelled, the value of, so this is the required differential equation which represents that which help us to calculate the rate of evaporation. So next question we have is that for a certain substance, the rate of change of vapor pressure with respect to the temperature. So rate of change of vapor pressure with respect to the temperature dt, right, is proportional to the vapor pressure and inversely proportional to the square of the temperature. This is proportional to the square of the pressure and inversely proportional to the temperature. It's proportional to the pressure and inversely proportional to the square of the temperature. So the question is decoded in the mathematical format. Form the differential equation expressing the given condition and verify that P is equals to AE. This thing must be verified that P is equals to AE raised to the power minus KT. So whatever differential equation, this is the differential equation and we are required to solve it, right? So solving the differential equation, a simple concept that the K must be eliminated. Some constant must be eliminated. So if we eliminate this constant, right, we will get the differential equation which should be of this format. It must be clearly understood or verifiable. So let us try to solve this. Here we have that dp by p, I have taken on the left hand side, k dt by t square. Integrating it on the both the sides, 1 upon p, its integration will be ln p is equals to k times 1 upon t square. So 1 upon t square is differentiation will be minus 1 upon t, right, minus 2 plus 1 minus 1. So minus 1 upon t and some constant c will appear in the equation. No need, here we already have the constant multiplied over here, so no need to add new constant. Converting it into a exponential form, e raised to the power minus k by t. So here we can see that this equation resembles this equation. If we would have added some constant c, the value of this constant can be obtained from some conditions. As of now in the question, the condition is not given, so I have ignored that c. But if we would have considered the c, and if the conditions were given, exactly the value of a also we would have determined. As per our solution, the value of a appears to be 1. Next, we have a question that says that show that v equal to a by r plus b, where a and b are arbitrary constants, satisfy the differential equation d2v by dt square plus d2v by dr square plus 2 by r dv by dr equal to 0. So here we have been given one equation, and this equation must be converted into a differential format which must be of this type. So in the while going through the basic concept of this chapter, I clearly stated that if there are two differential equations, right, the order of differential equation will be 2. So we can see here already they have given that when you solve this you will get the format of this type. But in case if this was not given, right, solving this equation, converting into a differential form will have highest order as 2. So let us try to solve it, differentiating with respect to r. So we have dv by dr is equals to minus a upon r square, and b becomes 0. Here we have r square dv by dr is equals to a, minus also we take it on the other side. So this is one part of the solution. Now let us solve it further. When we solve it further, u dot v, so minus as it is, r square would become 2r, dv by dr is differentiation with the r, so dv by dr will remain as it is, and then plus r square will be as it is, and differentiation of the dv by dr will be d2v by dr square is equals to 0. Minus sign you can shift on the other side and cancel it. So here we have d2v by dr square plus 2r dv by dr equal to 0, right? R square, taking out r common, or as exactly we want this type, so we'll take out r common, so it will be r d2v by dr square plus 2 by r dv by dr equal to 0. No, we have taken r common. Let's take it r one more time common, so it would be d2v by dr square plus 2 by r dv by dr is equals to 0. So this is exactly of this format. So here in this question, for looking at the question itself, it must be very clear to us, right, that since there are two constants, the differential equation, its order will be 2. If there are two constants, the order will be 2. If there is one constant, the order will be 1.